with radicals. So the outcome we're going to do is solve problems that involve operations on radicals and radical expressions with numbers and variable radicands. So this is grade 10. This is grade 10. This is your radical sign. This is the radicand. This is the index. This is the coefficient. So this is the number in front. Coefficient of any term is the number that's in front, right? It's in front of the coefficients of 4x squared would be 4, right? It's the number that's in front. So it's my coefficient. My index is a little number on the root. If there isn't a number there, we assume it to be a 2, right? Radical sign, radicand is what's underneath. Like radicals will have the same base and index. So just like 2x plus 3x, those are like terms. We can add them, right? Same thing with like radicals. You have to have like square root of 2 or both of them would have to be square root 2. If one was cube root 2 and one was square root 2, you couldn't put them together. Okay? So they have to have the same radicand, the same number underneath, and the same index. So they both have to be all square roots or all cube roots, right? In order to add them together. That's what we're going to do. A radical in simplest form is a radical term where the radicand does not contain a fraction, the radicand does not contain a factor that can be removed, and the denominator does not contain a radical. So this is simplest form. These three things. Your radicand can't have a fraction. So what's underneath the radical sign can't be a fraction. Why? Because if I had root 1 over 2, you guys, that's actually the same as root 1 over root 2, which messes with my third comment. My third comment says the denominator can't have a radical. Well, it does, right? So if you have a fraction under a radicand, it actually throws this one right out. You can't have a denominator, your radical can't have a denominator, or your denominator can't have a radical. And then the radicand does not have a factor that can be removed. So like nope. So pretend like on the test there was root 24. We could break that down to 4 and 6, right? So we could take out a perfect square out of it, a 4, then it's not in simplest form. So if you can take a perfect square out of it, if you can break it into a factor, the number into a factor with a perfect square in it, it's not in simplest form. That's what this one means. Okay. There are restrictions on the variable in the radicand. So if you have a variable in the radicand with an even index, the key thing here is an even index, then you're going to have a place where you have to state restrictions. Why? Because you can't square root a negative number. You can't fourth root a negative number. You can cube root a negative number. Now, why is that? If I take the cube root of negative 27, I can actually find that because the cube root of negative 27 is negative 3 times negative 3 times negative 3, and I can just pull a negative 3 out, and that would be my answer, right? Then you can take it out. So of odd indexes, you could have a negative under the root sign, okay? So cube root, fifth root, seventh root. It's only evens that you can't have a negative. So the radicand with an even index must always be positive. So we're going to have to state restrictions whenever we have an even index, so the square root or the fourth root or the sixth root or the eighth root, and a variable under the root sign. We have to state restrictions of what the variable can't be, or technically what it can be. So let's look at these. So the restrictions is the new part of this. The mixed and entire radical is grade 10. So we're just reviewing, okay? Mixed radical means some of it is outside of the radical and some of it's under the radical. So some of it's the radicand, some of it's coefficient. So this one is 5 square root 3. If it's in simplest form, this number under the radicand, I can't break down into factors that has a perfect square in it. So 3, I can't break that down into divided by 4 or divided by 9 or divided by 36 or divided by 16, right? 3 is as small as it can go. So this is the mixed radical in simplified form. This is a mixed radical in simplified form. Then we have to do an entire radical. An entire radical is everything is, the whole thing is under the radical. So the entire thing is under the radical sign. That's what an entire radical is. Okay? So what you have to do is you have to bring this back inside. How did we get the 5 out in the first place? What would it have been under the radical in order to get a 5 outside of the radical? 25, right? If you had 25 under the radical and you took the square root of 25, it would come out as a 5, right? So to make an entire radical, you basically just raise this to the index and bring it back inside. So that we have a 2 as the index, so we have 5 square root 3. We say, okay, how do I get it back in? I square it and I can put it back in. So I get the square root of 3 times 25. Because if I square this and put it back in, I get 25. If I, you know you're right, if when you take the square root of it, you bring it back out, it would be the same number, right? 5. Now you don't need the little 2. So when it's a square root, you just assume it's there. So this is going to be square root of 75. And that's the entire radical. The last thing they want us to do is state restrictions. One of the common errors that I see on your guys' tests in general is that you do not read the question. So if this was a question on the test, express each mixed radical in entire radical form, and then state the restrictions on the variable, you guys would ignore the state the restrictions on the variable, 90% of you, and just give me the mix to an entire. Okay? You're not answering what the question is doing. You have to write down at least what the heck it's asking you for. So it says express each mixed radical in entire radical form. So each of these mixed has to become entire radical. And then it says state the restrictions. So I'm going to read through and figure out what the heck they want me to do and do what I ask, right? A lot of you guys in written response get dinged super bad because you don't read the question. Or in numeric response, you get it wrong because you give me an answer to not what I asked for. Okay? So it's not that you guys don't know what you're doing. It's literally that you're not reading what the question's asking. Okay? And we don't want to get dinged on that because grade 12 diploma, you guys, 40 questions, 28 multiple choice, 12 numeric response. That's it. You don't even get part marks if you get it wrong. And it's worth 30% of your mark. It used to be worth 50 2 years ago, so much better. Each question on the diploma used to be worth more than 1% of your actual overall grade because it was 40 questions worth 50%. Yeah, it's crazy. So now it's at least every question's worth a little bit less than 1%, which is better. Still not fantastic, but much better. Okay, now we need to state restrictions. You state restrictions when there's something under the radical that could become negative. I have no variable under there, right? There's no letter under the radical. There's no radicand, that's a letter, so I have no restrictions. 3 can never be negative, it's 3. You only get restrictions when you have a variable or a letter under the radical. So if your radicand is a variable that contains a variable, then you will have a restriction, okay? If it's an even-powered radical. So now we have express each mixed radical in entire radical form. So we have to take it and make it entire radical form. This one is reduced to as low as it can go already. So this is mixed. Just in case you guys forget which one's which, this is your mixed radical. Mixed radical is you have part of it under the radical and part of it outside, right? It's mixed. Now, what did we say? If we want the entire radical, we have to take everything that's outside and put it, the whole thing under the radical, the entire thing under the radical, right? Entire radical. So what did we do? Well, I always write my index out if it's not there. So my index is a 2. What I do is, how did I get this out of here? I took the square root of whatever was under here and I got this, right? So how do I put it back under? I square it, I raise it to this exponent and put it back in and multiply it by whatever under there, right? To just go and undo what we had done. So if I square 2, it's 4. If I square b, it's b squared, and then put it back underneath. So I get b times 2 squared, which is 4, b squared, which is b squared. And then I always multiply them because they were multiplied before, right? That's what they were before. We're just putting them back. So now I get the square root of 4. And what do I do with these two? Do I say b squared or b cubed? Grade 10 exponent laws. When you have two bases that are the same, what do you do with the exponents? Add, right? Two bases that are the same and you're multiplying, you add the exponents. Two bases that are the same and you divide, you subtract the exponents, right? This is when you multiply. When you have one base and two exponents, like say you had it like this, then that would be b squared, right? One base and two exponents, you'd multiply them. But two bases and two exponents you add, so you get 4b cubed. So I answered my one question, which was, write the mixed radical into entire radical. So this is my entire radical. Now I need to state restrictions. And now I have to state restrictions because I have a variable in the radicand. So I have to figure out what b can be in order for this to never, ever be a negative, because I can't have a negative under the radical. So what you do is you can go like this. You can go, what number here, if I put something in here, would get me a negative under the radical? If I put 0, I'd get a 0. 4 times 0, right? Is that okay? Can I take the square root of 0? Trick question. Square root 0 in your calculator. Square root of 0 is 0. 0 is okay. You just can't have negatives, okay? So what if I put in a 1? Then I'm okay. What if I put in a negative of any kind? Any negative number cubed is a negative, right? So what do I have to say? B has to be greater than or equal to 0. That's my restriction. If B is less than 0, I'll end up with a negative number. Even if it's a decimal negative, it won't work out. Because when you cube a negative number, it stays negative. The next one, I want to make an entire. Instead of raising it to the 2, I'm now going to raise it to the what? What's my index? 3. So I'm now going to raise it to the 3. So I'm going to go negative 4x cube root of 7x squared. I'm going to take this and I'm going to raise it to this index that's right here. So technically I'm just doing what this looks like and putting it underneath, right? So I get 7 cube root of 7x squared. What's negative 4 cubed? And please, whenever you do any negative to any exponent, put it in brackets, right? So negative 4 cubed is negative 64, I think. Yeah. And then x cubed is x cubed. And then we multiply. What's 7 times negative 64? I do not know that. $448. X to the 6 or x to the 5? 5. Because when you have two bases and two exponents, you add them. And then this is an odd exponent again. So if I do any negative number in here, it's going to be negative, right? Any negative number to the 5 will be negative. So once again, x has to be greater than or equal to 0. Bless you. What happens if it's a squared underneath? So what if I had like 3x squared? Is there anything I could fill into x that would force this to be negative? This is a positive 3. Anything that I square will become what? Positive. If I take any number and square it, or to the 4, or to the 6, or to the 8, it'll become positive. So if this is a positive number, anything I fill into x will be positive. There's no restrictions on here. Nothing. Nothing can make this be negative. So I have no restrictions for that one too. Okay. This is a nice little handy-dandy table. It's not going to be given to you on your test. So if you want it on your test, you're going to have to take the time to draw it on your test. So perfect squares. So your perfect squares are 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. And then your perfect cubes are this. The times 2 is just like a nice thing, but you don't really need those so much as you need the perfect squares and the perfect cubes. Because we're going to try and figure out if we can divide by any of these, then we can reduce it if it's a square root. If we can divide by any of these, we can reduce it and make it a mixed radical if it's a cube. So now we're going to do express each entire radical as a mixed radical in simplest form. And then we have to state restrictions again. So ultimately, we want an answer with a mixed radical and a restriction, right? So this is square root of 192. So I'm going to try and figure out what perfect square I can divide 192 by, the biggest one, and reduce it. So what do? I start working my way down. I go 192 divided by 4, 192 divided by 9, 192 divided by 16, 25, 36, 49, 64, 81. I'm going to stop at like 181 because it's 192. So once I hit 100, it's not going to be divisible anymore. It's too big of a number, right? Like 192 divided by 100 is never going to happen. So you work your way down your list. 192 divided by 4, 192 divided by 9, 192 divided by 16, and you try and get the biggest perfect square. So when you divide it, you have to get a nice number, not a decimal. So 192 divided by 4 works. It's 48. But is there a bigger one? Well, let's see. 192 divided by 9, I get a decimal. 192 divided by 16, I get 12. Is that the biggest? I don't know. 192 divided by 36. No. 192 divided by 49. No. Decimal. 192 divided by 64. 64 and 3. Can 3 be broken down into any more perfect squares? No. So the biggest one we can break this down into is 64 and 3. Now, when I did 16, 192 divided by 16, I got 16 and 12. I knew that I had to keep going because 12 I can divide by 4, right? I can divide it by still another perfect square. So I need to keep going down the list till I get the biggest one. Oh, let me get my thing back again. So 64 times 3. Now some people pick like random numbers, like they'll go like 192 divided by 8, and if it works they try 8 and something. You need one of the numbers that you break it into to be a perfect square, because this is a square root. The only way I can pull anything out of that square root sign and bring it to the front is if it's a perfect square. So if you just divide it by random things, that's not helpful. You have to divide it by the list of perfect squares if it's a square root function. Okay? When I square root 64, what does it become? What's the square root of 64? 8. So I'm actually going to get 8 square root 3. That's my mixed radical in simplest form. Now, what's my restrictions on the 3? Because it just has to be what's under the radical sign. Because what's under the radical sign, the radicand, can't be negative. So what's my restriction on this one? There's no variable under the radical. So there's no way that that's going to become negative. It's a 3. So no restrictions. And you guys, restrictions are very important because in grade 12 we're going to be looking at equations of radicals and how they transform, stretches, reflections, translations, all that stuff. And you have to be able to give the domain and range. And the range is completely based, and the domain are completely based on the restrictions of the variable in a radical. So we need to know our restriction. Okay, this one doesn't have any numbers in it. The only way we can pull out a perfect cube is if we can get 3 of something multiplied. So let's look at a different example. Like I said, let's just use, I don't want to erase. Let's use square root, or the cube root of 27, let's say, right? How are we actually pulling a number out of a cube root? Well, if we can get 3 of the numbers the same, like we did with those factor trees in grade 10, you could take it out. So I could go cube root of 27, I could break down in 3 times 3 times 3, and because I have 3 of them, I can pull a 3 out. So it would actually be 3 cube root nothing. So it would just be 3. That's why the cube root of 27 is 3. So I have to break this y to the 7 up into groups of something that I can get 3 of. So what I could do is I could go y squared times y squared times y squared, but that's still only y to the 6, right? Because you add your exponents when you have common bases multiplied. So what am I left with? A y to the 1. If this is mind-blowing, you can just write out all the y's. So you could do it this way. You could go y times y times y times y times y times y times y. My nephew sent me a question like this, and he's like, I have no idea how to do it. So this is the easiest way for me to explain it. If it's a cube root, you have to be able to take 3 of it out, right? You have to have 3 of them multiplied together in order to take it out. So I can these are all 3 y's multiplied together, so I can pull out a y, and then these are gone, right? These 3 y's are multiplied together, so I can pull out a y, and then they're gone. And I'm still left with a y in here, correct? What do I do with these 2 numbers out here? Or these 2 letters, sorry, variables. I multiply them. What's y to the 1 and y to the 1? Y to the 2. So I'm technically left with y squared, cube root of y. If I did it this way and broke it down as y squared, y squared, y squared, and y1, I can take out, I have 3 groups of y squareds, right? That means I can pull the y squared out. These cancel, and I'm still left with the same thing. Right? Y squared and y. Whichever one, so this one here, y squared, cube root of y. Whichever one makes more sense to you, do. Neither is better. One just takes a little less y's drawing out, right? But whatever is easiest for you to understand. If it's just, I have to make as many of these as, and then I can take one out per each time I have 3 of these, then do that. That's absolutely fine. This is a cube root. I have no restrictions. I only have restrictions on even indexed radicals. So whenever you see cube root, usually people get sad because they're like, I like square roots so much better. But you should be happy because you will never have a restriction. So no restrictions. Because you only have restrictions on even indexes. So square roots, 4th roots, 6th roots, but not cube roots. Then flip over. If I want you to do this without technology, you can always check with your calculator anyways. But if I want you to do this without technology, you have to make them all under an entire radical and then just put them in list from smallest number under the radical to largest number under the radical if you're going from smallest to largest. So in ascending order means smallest to largest. So we need to make them all under mixed radicals. So this one here is already an entire radical. Sorry, entire radical. So root 149. How can I make this under a radical? The answer of 13. What would it have been as a radical? And these are all, you can only compare these also if they're all square roots or all cube roots. If you have some square roots with cube roots, you'd need technology. 13 is the answer to the square root of 169. Now, for root 10, we need to make it an entire. How can we put it back underneath? We have to go 4 squared, and then we can bring it back underneath. So this is actually the square root of 10 times 4 squared, which is the square root of 10 times 16, which is the square root of 160. So if ever I want you to list in ascending order or descending order, make into entire radicals. Just like I said, if I want this in vertex form, you have to complete the square. If I want these in ascending order, and it says without technology, and it's in a written response on your test, and you just use your calculator and write them in ascending order, I can't give you marks, right? If it was a multiple choice, I would know no difference, so I guess you could. But if it's a written response, you have to show me the work, right? Now, a half, you guys learned in grade 10, that say if I had, let's do this, 42 to the half, ignoring that there's a 2 there for now. What you can do is you can make this a radical. This is just the index. And this is the exponent. So how you would rewrite this is the square root of 42 to the 1. This number underneath is just the index of your radical. You learned that last year. This number underneath is just the index of your radical. So I can rewrite this 42 to the half as the square root of 42 to the 1, which is the square root of 42. So really, this is actually 2 square root 42. And now I need to make it an entire radical in order to be able to list them from smallest to largest. So I raise it to the index, 2 squared, drop it underneath. So 42 times 2 squared, which is 42 times 4. Is that 168? 42 times 4? So square root of 168. So right now I have root 149, square root of 169, square root of 160, square root of 168, and then this one I have to drop underneath again. So it's going to be 3 squared root 19. I take this 3 raised to the 2, and then drop it underneath. So 19 times 3 squared. 19 times 9. What's 19 times 9? 171? So now if I want to list them from lowest to highest, square root 149 is the smallest. Square root 160 is next. 168 next. 169 next. And 171. Now, they want me to arrange these numbers in ascending. So people will rearrange the end result, but that's not rearranging these numbers actually in order. So you'd have to arrange these ones up here. So I'm just going to list it like this. 1, this is number 1. This is number 2. This is number 3. This is the 4th one and the 5th one. So that's the order those go in without technology. So if you want to list radicals in ascending order without technology, you have to change them all to entires. Okay? Just like in quadratics, when I wanted it in vertex form, you had to complete the square. Okay? There are certain hints to tell you what you need to do. Okay, why did we go over mixed radicals in such importance? Because we're going to be doing operations with radicals. Okay? What's the great thing about radicals is they follow rules of polynomials. So with polynomials, if you have like variables, you can add them. So like 2x plus 3x is 5x. However, if I had 2x squared plus 3x, it would be 2x squared plus 3x. I couldn't put them together. They're not like. Same thing with radicals. They have to have the same index and the same radicand in order to add them or subtract them. So right now you'd say, well, I'm done. There's nothing I can do. Simplify the radicals and combine like radicals. So remember, like radicals have same index and radicand. Same index and radicand. So some people will say, okay, that's good. I'm done. I can't even put them together. There's root 27 and root 12. They're not the same. We have to reduce them. We have to make mixed radicals, simplified mixed radicals. So this is why your square root and cube root chart are going to be of importance to you. Square root of 27. I can break that down into what perfect square? So I go 27 divided by 4, 27 divided by 9, 27 divided by 16, 27 divided by 25, 27 divided by 36 makes no sense. I'm way too big now, right? So what does it break down into? What perfect square? 9 and 3, right? So I always list my perfect square first. So 9 times 3. And I can pull that square root of 9 out, and it becomes what? What's the square root of 9? 3. Then this goes away. So I'm left with 3 root 3. Okay? Plus sign. 2 root 12. Well, I have to break 12 into a perfect square. So I go 12 divided by 4, 12 divided by 9, 12 divided by 6. I'm too far, right? Like you can't divide by a bigger number than it is. So 12 breaks down into 4 and 3. So I write the 4 first because it's my perfect square. I take the 4 out and it becomes a 2. What do I do with those two numbers? Multiply them. So if there's already a number out front, you have to multiply it with it. 2 times 2 is 4 root 3. So the mixed radical part is all grade 10. Making it to simplified mixed radical is grade 10. The new part, the grade 11 part, is adding them. And now I can actually add them because they both have root 3s, right? So just like if I had said 3x plus 4x, you'd tell me that's 7x, right? So 3 root 3 plus 4 root 3 is 7 root 3s. So same rules as polynomials. Just the root 3s are like x's, okay? Let's try the next one together. So we have 5 root 8. 5 square root 8. What can I break the square root of 8 up into? 8 divided by 4. 8 divided by 9. Oh, we're too far. What can I break it into? 4 and 2. So I write the 4 first. And then when I take that out, it becomes a 2. And I multiply them. So I'm actually left with 10 root 2. Minus 3. 18, what can I break it into? Elizabeth, what can I break it into? 9 and 2. I take that 9 out and it becomes a 3, because the square root of 9 is 3, and I multiply them. So I get negative 9 root 2, and then plus root 3. Is plus root 3. There's nothing I can do. Which ones can I put together? The root 2's, right? The 3 I can't do anything with. So I'm going to be left with 10 minus 9, 1 root 2, or just root 2, plus root 3. That's as nice as it gets. I can't put the root 2 and 3 together. They're different. It's just like an x and an x squared, right? Or an x and a y. You try the next one. The key thing here is I can't take out the a's because they're just an a. I'd need 2 a's in order to pull an a out, right? This is to the 2. So I'd need 2 a's in order to group them and pull 1 out for 2. Okay? So you try it out. So 32. I can break into what's my biggest perfect square? I can break 32 into, Annie. 16 and 2. So 16 times 2 times a. I can take the 16 out and it becomes a 4. 3 times 4 is 12. Square root 2a. If this was an a cubed or something, then I could break it down into like a squared and a and take an a out. But it's just an a. I can't group it and take anything out. Minus 4. Square root of 162, what perfect square can I break it into? Christina. How much? 81 and 2. When I take the 81 out, it becomes a 9. Negative 4 times 9 is negative 36, root 2a. And then I can actually put them together because they both have the same radicand and index. 12 minus 36 is negative 24 root 2a. That's a 2, even though it does not look like a 2. What's the catch on the next one? This is root 2a. What's the catch on the next one? Cube root. So you have to break it into the cube roots. So instead of dividing it by 4 and 9 and 16 and 25, you're going to divide it by 8 and 27 and 64, and now we're too big, right? So it's perfect cubes. So you go to your perfect cubes list, which is on the previous page, and you look at the first row of numbers. There's 2 cubed, which is 8. So 80 divided by 8 is 8 and 10, right? That's the biggest we can go. So you'd break this down into 8 times 10. What's the cube root of 8? 2. So you're actually left with 2 cube root 10. Remember this mixed radical stuff from grade 10, right? Plus, I would always try 10 right off the bat and see if it gets me a perfect cube with it, because hopefully they're the same radicands and I can add them. It's kind of like a hint, right? They might not be, but they could be. The perfect cube that this breaks down into is 27 and 10. Cube root of 27 is 3. So 3 cube root 10. And then they're added. 3 cube root 10 plus 2 cube root 10 is 5 cube root 10. Oops. So now, the next one, we're going to break down those cube roots first, and then we're going to have to actually get common denominators in order to add them. So this is the hardest way we could do it. So the cube root of 64. What's the cube root of 64? It's actually 4, right? That one's, I know the moment that I make something actually common, like a perfect cube, people like mess up because they're trying to find what other number can work into it, and cube root of 64 is just 4. 375. So I go 375 divided by 8 first. No. 375 divided by 27. No. 375 divided by 64, which is 4 cubed. No. 375 divided by 125, which is 5 cubed. Does that work? Yes. 125 times 3. The cube root of 125 is 5. So I'm going to get 10 cube root 3. The cube root of 54, I can break that down into 27 and 2. Over 3. Cube root of 27 is 3. So I'm actually left with minus 6 cube root 2 over 3. And then 24, I can break down into 8 and 3. Take out the 8, and I get a 2. And so I'm left with minus 10 cube root 3 over 2. And 4 over 8, you guys, I could reduce to a half, correct? So I'm going to do that. Bigger. Now this one is tricky because the only way I can even add these before even worrying about the radical adding is they have to have common denominators. It's fractions. Obviously, this is not the most common type of question you're going to get on your test. This would be like a standard of excellence hardcore question, right? It's combining a whole bunch of rules. So first off, I'm just going to try and make common denominators. So I'm going to get them all over 6. So I'm going to times this one by 3 over 3. And then I'm going to times this one by 6 over 6. I'm going to times this one by 2 over 2. And I'm going to times this one by 3 over 3. So that I can get a 6 on the bottom. Oops. So here I'm going to get 3 over 6. This one I'm going to get 60 root 3 over 6 because you just multiply, plus. You just multiply the coefficient by the number. So it's 60 cube root 3 over 6 minus 12 cube root 3 over 2 over 6 minus 30 cube root 3 over 6. And now you can write them all over 6 and just combine the ones with the same radicands. So I would get 60 cube root 3 minus 30 cube root 3 is 30 cube root 3. Nothing matches this one, so minus 12 cube root 2. And nothing matches that one, so plus 3. Like I said, this is standard of excellence, right? And to be honest, I could take a 3 out of all of them. This would become 10 cube root 3 minus 4 cube root 2 plus 1 over 2. You can take a number out of all the coefficients and the bottom, you could take it out. Now we're just going to flip to the very last question before the homework. It's the shape one. And you were given shape ones like this last year, you guys. This weird shapey type thing where you had to find the perimeter of the shape or the area of the shape. You were given this in grade 10. Not as much with radicals, but you were given it in grade 10. So let's look at this shape. And you can fill in the numbers because they're a little shady. This one is 8 root 2. So if you want to make yours a little darker, you can. This is 8 root 2 plus 2 root 2. This is an x. This is 5 root 27 minus 4 root 18. This one says, this one's even better because it's not perimeter and it's not an area question. It literally just wants you to find the length of x. As an exact value means no decimals. You can't just plug it in your calculator and give me an answer with a decimal. If you do that, you get no marks. Okay? It's a radical unit. If you could just plug it in as a decimal, it kind of defeats the purpose of it being a radical unit. So, how can we get the length of this? What can we do to get this length? Yeah? So you want to subtract this one from this one. Yeah. So if you subtract this little side here from this big length here, you'll be left with the little length, right? Because it technically makes a box. So this length plus this length equal that length. So if I just take this big long length and subtract this, this is where people error. So 8 root 2 plus 2 root 12 minus 5 root 27 minus 4 root 18. You have to subtract the entire thing. You need to put it in brackets. So whenever there's more than one term behind a subtraction sign, you guys, you have to put in brackets. That's where everyone errors. If you're like, yeah, I wouldn't have done that, leave yourself a little note and say, make sure that the second half you put in brackets behind the minus sign, because that's a common error. Okay, that's the biggest error out of all of these is going to be that bracket. So if I made a multiple choice question, I'd give you an answer where you had the bracket, which would be correct, and an answer where you didn't have the bracket, and I'd probably have a large amount of you picking the answer where you didn't put the bracket, because it's the biggest common error, okay? The only way I can add and subtract radicals is if they're in simplest radical form. So your simplest mixed radicals. That's what we have to do first. 8 root 2. I can't reduce root 2, right? I can't take any perfect scores out of it, so it's done. So that one's nice. Root 12. I could break down into 4 and 3, right? 4 and 3. The square root of 4 is 2. So it comes out here. Cross it up. Now this minus sign goes to both of these. So it's actually going to be minus 5 root 27 and plus 4 root 18, right? That minus sign goes to both of them behind it because you're subtracting it. You're subtracting 5 root 27 and you're subtracting a negative 4 root 18. And when you subtract a negative, what do you actually end up doing? Positive. Adding. So we're going to get 5 minus 5 root 27. I can break down into 9 times 3. Take the 9 out and I get a 3. Plus, because it's minus a minus 4, plus 4. And 18 I can break down into 9 and 2. Take the 9 out and it's a 3. So now I'm left with 8 root 2 plus 2 times 2, so 4 root 3, minus 5 times 3, so 15 root 3, plus 4 times 3, so 12 root 2. And then I can only collect the ones that have like radicands. So 8 root 2 plus 12 root 2 is 20 root 2. 4 root 3 minus 15 root 3 is minus 11 root 3. That is the answer for A. X equals this. That is the exact value. Now, B says as a decimal to the nearest tenth, go 20 root 2 minus 11 root 3 in your calculator. And you get 9 decimal 2. Okay, page 278. I'm going to be doing homework checks every day, but I'm doing homework checks of 3 questions. So you'll find out when I homework check it. So for 2 and 3 and 4 and 6 and 8 and 9 and 10, for all of these ones, I want you to do 2 questions. So A and C. I want you to do 2 questions for each of them, A and C. I should take out the 2 questions. That doesn't make any sense. For each of these, I want you to do part A and C. 2 questions means like you think like I could do 2 out of all of them, but no, that's not it. That's a terrible lie. And then do just 11. So I knocked out 2 word problems. You should be happy with that.